Tiny Planet Inc. Global Reach, Local Talent.
Hello everyone. I'm Sonali. Hi.
Hi.
So I'm working in this IT field. Hello. So I'm working in this IT field since last 16 years. And out of that, I spent last 8 years into the software testing and quality. I was especially working in the area of business intelligence, and I have also took trainings on different certifications like CSQA and general ISTQB and software testing courses. I'm very glad to conduct this online training for you. And these are the course contents which will be covering into today's session. So we'll start with some quality basics. Yeah, one more thing I would like to clear here is that as per my discussion with this Tiny Tot counselor, I have prepared this training assuming that the participants do not have any QA background. So that's the reason I have started with a very basic quality concepts. So we'll start with the quality basics. Then we'll look at the need and advantages of having quality function in the organization. Then we'll see the quality implementation and management, the different levels of testing, the different types of testing, and the different methods of testing. So basically QA or quality or software testing is a very vast subject, and it is not possible to cover everything in this session, but I have chosen the things which are very, very important and which can give you an overview of a software testing and quality function. But if you look at each of these topics can have a different 1 hour or even more than that session on quality. So to set the expectation, we are just going to touch or look at these topics at a very, very high level, at a very, very short span. So it will just give you the overview of all these topics. So I hope the slides are refreshed, right? Can you see this picture on your screen now?
Yeah, I see.
Okay, good. So if you look at this picture on your screen, there are 4 people who are examining the objects placed on the table. So they are basically examining the quality of this object. And we can assume that every one of them can have a different quality perspective. So one of them might be thinking about the thickness of this wooden log. The other person is examining that log on the basis of its durability. One may be interested in having the good look and feel, etc. So everyone in the room can have a different quality perspective. So quality is basically a relative concept which differs from person to person. And same thing applies to software application, the software project, that each one associated with the project or product can have different quality perspectives. So let's have a look at the producer's perspective of quality. What do producers think when he is basically trying to provide a quality product to the customer? The very first thing in the producer's mind is doing the right thing. Doing right thing is whatever has been asked by the customer, the producer always tries to produce that type of a product. So conformance to requirement whatever requirements has been given by the customer, he will try his best to prepare a product in conformance to that. That is the basic, the very important thing from a producer's perspective. Then another thing is doing it the right way. So the methods, the methodologies used, for example, the project management methodology or the quality assurance methodology or the communication method. So whatever methodologies they are being used, they should be used in order to deliver the right project. And of course, doing it right the first time is equally important. So the project should not be failed, should not have a major defects or problems while delivering. There might be small issues which can be corrected, but it should not be major issues, and the first delivery of the project should be right. So doing it right the first time is another very important thing from a producer's perspective of quality. And doing it on time without exceeding cost. So whatever is the schedule agreed upon by before the project started, it should be delivered within that schedule, within that cost. So these are the very important points if you talk about the producer's perspective of quality. Then the next thing is customer's perspective of quality. So customer can be a consumer, can be an end user, or a person who is providing that product to another user. So for the customer, receiving the right product for their use. In other words, you can say the product or the software application, if it is fit for their use, whatever is the objective of building this application, that should be fulfilled. So that is a very important thing from the customer's perspective. Then being satisfied that all the needs of a customer have been met. So, you know, sometimes customers are not able to provide all their needs. They definitely provide the requirements to the producers, but sometimes they are not able, or they cannot capture all their needs in a documentation. So producer has to take that end user perspective and should understand how the customer is going to use the product, and then add certain things into that product so that the customer's needs should be satisfied, because that is a very important point from the customer's point of view. Then meeting their expectation, the software product should meet their expectation in terms of usability, the functionality, the look, etc. That also is another important point. And the last point, being treated with integrity, courtesy and respect, is with respect to the communication. So throughout the project development life cycle, it is very important that the customer should be informed, and he should be informed on a very honest and genuine status of the project. If there is anything, if the schedule is going to be slipped, or if you are delaying the project delivery due to certain reason, it is very, very important to keep the customer informed, so that he'll have a confidence on you, and he'll be satisfied that he is involved in the status or whatever is going on the project activities, if there are any issues or if there is going to be any delay in the delivery. So this is what a customer expects from you, from the producer. So in short, quality is conformance to requirements and fitness of use. So if you want to have a very short, very concise and a one-line definition of a quality, then we can say that it is basically conformance to requirements and fitness of use. I'm sorry, there is a little disturbance here. Okay. So let us have a look at the quality assurance concept. Quality assurance is all about the preventive measures taken to ensure quality. So these are the measures taken beforehand to ensure that the whatever software application or product we are going to develop, it has to be, it has to have a minimum level of quality and should be defect free. So some of the QA activities are the correct process identification and implementation. So the right process, the process which we are going to follow during the development of the application has to be identified first, and we have to ensure that this right process is being implemented throughout the project life cycle. So having a right process at place definitely avoids the problems and issues. Then the correct plan for regular project audits. So whether the project is following the identified process in the right way or not, for that the regular audits needs to be performed on that project. Then this is very important to have the appropriate risk identification and mitigation plan. So before you start into project development, it is a good practice to identify all the risks and then should have the mitigation plans ready. So in case wherever this particular problem or issue occurs, you should be ready with a thought process that these are the steps which needs to be taken in case if this particular problem occurs in the project. So it's a very good thing to be well prepared. And then team trainings is again a quality assurance activity. So if, for example, if particular project development needs the people to learn a new technology and then the project has to be built into that technology, it's not a good idea to start training the people once the project has started. So this needs to be identified, that what different trainings needs to be given to the team so that they can deliver a quality product. Or in case if there are some newcomers who have just joined the team, then they should also be given trainings and orientation so that they can deliver well, on time and with quality. So these are all some of the QA assurance activities. So it's all about taking actions to prevent the issues and deliver a quality product. Then coming to quality control is all about the detective measures. So once the software is developed or once the software is started developing, then what all detective measures can be taken to ensure that the product will be a quality product. So some of the QC activities are the project review. So the requirement review, whether the requirement is valid, whether the requirement is clearly documented, whether the design is correctly documented, the design reviews, the code reviews. So all type of reviews, project reviews, they come under the QC activities. Then test planning and test case designing. So when the development team is busy in designing the project, the test team has to work on test planning and test case designing. Then test execution and testing. So once the product is ready, the test cases can be executed, the testing can be done, so that in order to detect the issues if any. And defect identification and reporting. And once all the defects are reported, development team has to fix those bugs, and then regression testing is done in order to ensure that all the reported defects have been resolved and fixed and the application is working as expected. So these are all the quality control activities which basically deals with detecting reports and getting it fixed. And of course all the project reviews also come under this quality control. Then let us have a quick look at the QA versus QC points. So QA is proactive, whereas QC is reactive. So QA is all the activities which are being taken in order to prevent the issue. So these are the proactive actions. And QC is reactive. So once the project artifacts have been prepared, QC is all about detecting the issues and then responding to those issues. So that is why QC is called as a reactive action. QA is prevention and QC is detection of issues and problems. QA is a wider function and QC is a part of it. So QC is a part of the quality assurance function and QA is a very wider function. QA is a senior management function basically. So like identifying the process and identifying and implementing the process is a senior management function. Or team trainings, this is a senior management function. We need to have approval for the team trainings and other activities. So QA is basically a senior management function and everyone's responsibility, whereas QC is a team or a department function. QC is basically done by a testing team or a quality department or in the organization. QA is a continuous function. So quality assurance activities start even before the project starts or with the project, and it will continue throughout the project life cycle. Whereas QC is a phase in a project life cycle. So QC is basically deal with the basically testing and reporting issues, and that is a phase in the project life cycle. So I hope it's clear.
Yeah.
Okay, I'll move. Okay, so I'll move ahead. So let us have a look at need of quality function in the organization. Why do we need this quality function? So role of quality function. The role of quality function is to ensure identification and implementation of appropriate processes like the project management process, the change management process, the defect reporting process, the communication process. All these processes has to be identified, and quality department or quality function is responsible that this process have been identified beforehand. Then ensure the clarity and validity of the requirement. So sometimes the customer just gives you a single line requirement and there can be n number of interpretation out of it. So quality function has to ensure that whatever has been asked by the customer, whether all the teams, the development team and the testing team has understood the meaning of that requirement. Or sometimes even the single line requirement can break up into 2 pages requirement. That is what my experience was. So a single line requirement has been given by the client and then later on we actually documented 2 pages out of it. So that is how it is. It can be documented in very detailed. So quality function is to ensure that the requirement has been understood correctly, what the customer is willing to say, whether the same interpretation of that requirement has been done by the quality team and the development team. And of course the validity of the requirement. So each and every requirement has to be associated with the test case. So how the testing team or even the development team ensures that this requirement is fulfilled, this requirement is developed in the project. So that is why each and every requirement has to associate with a test case. And if that requirement cannot be associated with a test case, that means if that requirement cannot be tested, then that requirement is said to be invalid requirement. So that is the level of clarity and validity of the requirements, and the quality function is responsible to ensure that this clarity and validity of the requirements are there. Then ensure project reviews and audit. Ensure that there is an appropriate project to have a project documentation and artifact reviews and audits. They have been performed on the project documentation as well as project code and project design. Then ensure that the product is being developed as per the requirement specification. Then ensure that everything, basically everything is at place. So whether the resources have been, the human resources as well as the hardware and software resources have been captured or not, whether the development and test environments are ready or not, whether the team is trained or not. So whether everything which is required by that project or application to have a good quality, whether everything is at place is not. This is basically the responsibility of a quality function in the organization. Then advantages of having a quality function in the organization. So when you say that we have a different quality function, we have a separate quality team who will be responsible for the quality of the end application, the end product, then that gives clients a confidence to receive a good quality product. So to win clients' confidence, it is very important to have a separate quality function. To avoid project failures, so if the thorough testing is done before delivering the project will not be failure in any aspect when it is delivered to customer. To avoid the rework, the repeated fixes and patches. So if there are a lot of issues, then to fix those issues and defects, there will be a lot of rework. So in order to avoid the rework, should have a quality function working in the organization for that software application or product. And of course, to have a different set of eyes looking at the product. So a quality from a developer's perspective is different from a quality of a tester's perspective. Because, you know, if there is a different understanding, developer may understand a particular requirement differently and a testing team may understand it differently. So whenever there are differences of opinions in a particular feature, then it's a good idea to involve customer there itself and get everything clarified, so that there would not be a lot of rework once the product is delivered. Then changing it is not a good idea. So it is good to identify all the issues early in the project life cycle. So an issue found early will be less costlier than the issue found later. So having a different set of eyes looking at the product is always a good idea, so that if there are any discrepancies, any issues, they has to be uncovered in the early stage of project life cycle. Then the cost of quality concept. So, I mean, there is a myth in the industry that involving a quality function or a separate testing team or quality team may increase the cost of the project. But that is not correct basically. So cost of quality is what? It comprises of the prevention cost and appraisal cost. Prevention cost is the cost rises from efforts to prevent the defects. So the reviews, the trainings, having the right processes, the cost associated with taking those actions. And appraisal cost is the cost arises from the efforts to detect the defects. So the testing and reporting of issues before delivery of the project. So this is basically the cost of quality. But if you compare that with the cost of failure, so if there is no separate quality function implemented in that organization, then there is a risk of having a cost of failure associated. And you know, this cost of failure is much higher than having a cost of quality. And then again, another important thing is you will lose confidence. So next time that particular client will not be willing to work with you if there is a lot of cost of failure. So cost of failure comprises of the internal failure cost. So the cost arises from the defects caught internally and efforts taken to correct them. So even if the reports, the issues have been found internally, if they are found later in the project life cycle, so after implementing, after developing the entire project, then correcting that is going to be costlier. And external failure cost is the cost associated with the defects that actually reach the final customer. So this is hampering the image of a producer. So if you look at this cost, it will be higher, much higher than the cost of quality. So it is advisable to include the quality function in each and every project in order to avoid the cost of failure and to lose the client's confidence basically. So that is why having a quality function is a good idea. Then let us have a look at the quality implementation and management thing. So this is the software development life cycle. Typically, I mean, these are the typical steps. Then there could be n number of different steps or stages depending on the type of project. So in general, there are requirement and analysis, planning and designing, development and implementation, then testing and bug fixing, and then deployment and maintenance. This is a very, very general life cycle of any of the project. And depending on the model you are used, the project, type of projects, and the requirements, this model can change and the phases can be rearranged. So there can be requirement analysis, planning, designing, and development can be a parallel steps. That depends on the project implementation, what methodology you are using and what is the requirement of the project. But in general, these are the phases in any of the project life cycle. And if you can see, quality assurance is throughout the project life cycle. So quality assurance starts even before starting the project. It will continue during all the phases of the software development life cycle, and it will be a continuous process. It will continue till the end of the project. Now, what this quality function will do? So when the development team is doing requirement analysis or planning and designing, what the testing team will do? So for that, this is a V model. This V model is basically maps the activities of the development team and testing team during the different phases of software development life cycle. So while the requirement analysis, gathering analysis phase, the development team is doing the requirement analysis, whereas the testing team is basically planning for the acceptance test cases, acceptance test planning. So acceptance test planning is done by the end user to ensure that the product is being developed as per their expectation. So each of the important requirement is associated with the acceptance test case, and these test cases will be executed by the business analyst team and the end user if possible together to ensure that the product is developed as per their expectations. Then when the development team is busy doing the high level design, the testing team plan for the system test cases. System test cases is when the development team would start building the application. These will be the test cases that will be executed to ensure that the building is done correctly. When the development team is busy doing the detailed design, the testing team plan for the integration test cases. Integration test cases is having different modules integrated together or different units integrated together, and how to, we'll come to it later on, that all these types of testing and the details of that. But basically this is the idea of the integration testing, to test different units of the application together. So when the development team is busy doing detailed design, the testing team works towards integration test cases. And when development team is actually writing the code, then the testing team can look at the unit test cases. So quality is basically an end-to-end function which will start with the beginning of the project and continue during all the phases. This is the overall idea behind this V model. Then software testing life cycle. So testing team also has to do the requirement analysis from a testing point of view so that they can do a test planning. Test plan is, we'll again going to see that the different test artifacts and what is going to be there in a test plan. So test planning is another phase after requirement analysis. Test case designing. So when development team is busy doing their designing, application designing and coding, the testing team has to work on test case designing, test scripting if any, and writing the scripts for populating the test data. Then testing. So once the test case designing is ready and the development team is ready with the code or with the application, the testing team has to start the actual testing. They start executing the test cases and report the defects, if any, in that application. Then once the bugs all the bugs have been reported, development team has to fix those bugs. Bugs is nothing but a defect. To fix all those defects, issues which has been reported by the testing team, and then the testing team again has to do a regression testing to ensure that all those bugs have been fixed, and the features, whatever features they were working in the earlier way, they are working exactly the same way in this new code as well. And sign off. So the QA team is responsible for signing off the application for production. So once the QA team says that yes, this application is ready and fit for use, then that formal process is called as a sign off. So unless QA team sign off the project, it will not go into the production. So sign off, QA sign off is very important. So that has been the last step in the project life cycle. So defect life cycle, how the defect life cycle is a journey, basically journey of a defect from its identification to its closure. So how the bug travels from different states. I'm sorry. So as soon as a new defect is found by the testing team, that is reported. So typically any of the bug reporting system like Bugzilla or Jira, there are different open source tools available to track these bugs. So the bug is being reported to that system, the defect tracking system, and whenever a new bug is reported, the status of that bug is new. Then after that, the development team has to accept that bug. So the development team reviews the bug, and if they found that yes, they try to reproduce that in their machine or in their environment. If they could reproduce that defect, then they'll accept that bug. So once the development team accepts that bug, that gets into the assigned state. But if the development team is unable to reproduce that bug, or if they believe that this is something which is expected, then they can change the status to invalid. That defect becomes invalid. And then we have to involve more higher function like the business analyst or sometimes the end users to ensure that this particular bug is invalid or not. If they agree that this is an invalid bug, then it will be closed later. And if the development team agrees that this is a bug, they'll accept that, and then the status of the defect change from new to assigned. Once that bug is accepted by the development team, they work on that and they fix that bug. If the bug is fixed, then it will go to a completed state. If the development team is unable to fix that bug because of any reason, so maybe because of lack of time, it may be because they are going to release this functionality in the next release. So there could be different reasons why this particular defect cannot be resolved. And in that case, that defect has been deferred. So the state of that defect has been changed to deferred. Deferred means that will be resolved later in some upcoming build or release. And if it is resolved, that will be completed. After the bug is resolved and completed, the testing team again has to ensure that the fix of this bug is satisfactory. If they find that the bug resolution has been done in a satisfactory manner, testing team can close that bug. If testing team found that the bug is not completed or not resolved as expected, then they can reassign that bug to the development team. Then it will go into the assigned state. Again, the developer has to either resolve or defer that bug, and then again the testing team has to test that. If it is satisfactory, testing team will close all the bugs. So this is a typical defect Lifecycle, a journey of a defect from its identification to its closure. Quality metrics. So typically the reporting is being done to customer on these metrics. So the total number of defects found in the application or in that particular release or build, the number of defects which are open as of date, and open means unresolved. Defect age. So defect age is basically the defect resolved date if the defect is resolved, or current date if it is not resolved, minus the defect reporting date. So how many days is required to close the bug, or if the bug is still open. That is the age of a defect from open to resolved state. Then defect density is the total number of defects found in that software application divided by the size of software component. So size is basically, measuring size of a software component is done differently by the different project teams. So each and every stakeholder, each and every team who we are involved in this project, they need to agree upon by this size. So that is the defect density. Then test artifacts. So there are different test artifacts which needs to be produced by the testing team. So first and very important is test plan. So test plan will have a test scope. So what all features the testing team has to test, what all features they are not supposed to test. All this it will come under the scope of a test. Then test strategy and approach. What approach is followed? What is the strategy that will be followed during the testing phase? The schedule of a test, different resources. So it will have human resources as well as the software and hardware resources. The sign-off criteria has to be agreed upon by all project stakeholders right during the planning phase, so that later on the decision making will be easier. So sign-off criteria and risk and mitigation. It is very important to identify all the risk and have the mitigation plan, mitigation strategies at place while developing a test plan. Then test cases and test scripts, these are again the very important artifacts of which has to be produced by a testing team. The test cases will have a test case title, the testing steps, how this particular test case needs to be executed. All those steps will come under testing steps. Then what is the expected result when you execute this test case? What is the expected result? And when you execute this test case, the actual result needs to be recorded. And then you'll have to check if the expected result is exactly equal to the actual result, then the status will be pass. If the actual result is not exactly same to the expected result, then the status will be fail. And for each failed test cases, there will be a defect reported in the defect tracking system. Then test script. So test scripts are typically prepared for the test data population. So testing team, they typically do the testing in a QA environment, and development team are doing the development in a development environment. So development team populates their own data while doing their development, then they release the code to a QA environment, and the QA has to populate their own data in order to test the application. So for populating that data into the QA database, there should be a data population script, so that whenever you get a new build, you will have to populate that test data and then execute the test cases. Test case automation. So if there is a particular test suite which needs to be executed again and again in the software, then that suite is automated. Suite is nothing but a group of test cases. So that test suite is automated, and those automation scripts can be a part of the testing team's deliverables. And data verification, SQL script. So that this is typically in terms of any SQL script or any of the Excel script. So this is to ensure that the data which is being shown on the UI is correct, and this is applicable to mostly reports data reports, dashboards, and BI application. So the data which is being shown, the derived data which is being shown on the UI, to check the correctness of that data, the testing team has to write the SQL script, and that is also one of the important deliverables of a testing team. So this is all about the test artifacts. Now levels of testing. So levels of testing are the different testing which is being done in different phases in the project life cycle. So the very first phase is unit testing. A unit is the smallest testable part of the software. So it is a good idea to test each and every unit of the application, so that whenever these units are integrated, there will be less number of issues into that code. So unit testing is done at the level of individual unit of the software development, and this is generally performed by the software developers. So the developers who are writing that code, they need to do this unit testing to ensure that the code is fulfilling the objective. But sometimes even the testing team is involved in doing the unit testing. Then integration testing. So when these different units have been integrated together, how they are functioning, this is basically the integration testing. So for example, if you look at the vehicle manufacturing process, there are different parts of the vehicles can be considered as different units. So one part of a vehicle is one unit that is being tested and that is working fine. But when that is integrated together and a vehicle is formed, it is very essential to test the functionality of an overall vehicle. We cannot assume that all the parts are working properly, so the integration would work properly. It's not the case. So it is very important to basically test when all those units are integrated together. So this is basically all about integration testing. It generally exposes the defects in interaction of individual units or components with each other. So either the developers or testers perform this testing depending on the integration and release plan. So if this particular group can be released to QA for the testing, then QA team can perform this testing. If the developer feels that we cannot release this code to QA, then development team has to perform this integration testing in their own environment, in development environment. And then system testing. So system testing is performed when all the components, the entire end product is ready. The purpose of this testing is to check if the system performs as per the requirements and report the defects if any of the functionalities are not working as expected. And this testing is done by the testing team when the code is released to QA. This is a very important level of testing wherein we expect maximum number of defects to uncover. And then acceptance testing. This testing is performed by the business analyst and if possible by the end users to ensure that the system is being developed as per their requirement and the readiness to deploy it to production. So once the acceptance test cases are passed, then the application can be deployed to the production environment. It can go to production. Then let us have a quick look at different types of testing. So functional testing is performed to ensure that all the functionality features of the system are working as per the requirement specification. This testing is done by the testing team and all the functional test cases are executed and the status is recorded. If the functional test case is failed, then the defect is reported in the defect tracking system. Then UI testing is basically performed to ensure that the user interface is designed as expected and the look and feel and ease of use are basically very important factors which needs to be tested during this UI testing. Security testing. Security testing is basically performed to ensure that only authentic users have access to the system. There will be username, password, and the different set of privileges assigned to different teams. So for example, there would be a different set of privileges assigned to the admin user. There will be a different set of privileges assigned to manager. There will be different set of privileges assigned to the operator of the system. So the different level, whether the different users are accessing the requirement, the information which they are supposed to access. This is the basic criteria behind this security testing, to ensure that everyone is having access as per their roles and as expected, as they are supposed to see. And data testing. Now data testing is a very important concept while testing the dashboards, reports and the business intelligence applications. This is performed to check the correctness of data that is being derived by the system. It ensures the data calculations and derivations performed by the system. So we need the SQL scripts to ensure this data correctness of data. Then performance testing is done to check whether the system's performance is as expected under a normal workload. And load testing is basically performed to check the behavior of the system under increased workload. So for example, if the client has given the requirement that there will be 100 users who will be using the system simultaneously, then testing the system with 100 users is a performance testing, and doing that with 200 users is a load testing. So increased load. There will be increased number of users, there will be increased number of applications that are taking the server's bandwidth. So load testing is being done with this additional load which is being created, and we'll have to see how this application work under this load. And this stress testing is basically to see where this application breaks. So the application might be working for 200 users, but the moment the user becomes 210, that application is failing. So identify this breaking point is basically the main objective of stress testing. So if the user expectation is 100 users, we can say that okay, for 100 users it is working fine. For 200 users also it is working, but working little slow. But it is going to fail when you add 210, any number of users more than 210. So this is what the inference which can be drawn out of these testings. So the end user, the customer would be knowing that okay, I can at the most add these many number of users or these many applications or these many load to my server in order that my application should work in a good manner. The responsiveness should not affect. This is basically the overall idea behind doing this performance testing. Then regression testing, we already discussed this, that regression testing is performed if any changes are made to the system to fix the bugs or to add the new features to it. This testing is performed to ensure that there are no deviations to the system functioning after the changes are made. It also ensures that the new features added to the system are working as expected and the old features are not affected due to this change. This is also very important. And during this testing, the test team has to ensure that the fixes to all the bugs are satisfactory. Smoke testing. Smoke testing is performed on a new build or the new set of code which is released to QA to ensure that the important functions are working properly and to ensure that this particular build is testable. This is a very quick testing, has to be done in 2-3 hours. This is not the exhaustive testing. This is just to ensure that the new build given is testable and the important features are working fine. The QA team can reject the build if it does not pass the smoke test. So the developer has to fix all those issues and then release it to QA. Usability testing. So this is basically the testing which is done from the end user's perspective to evaluate if the system is capable and convenient for use. This is to ensure that the system enables the business functions to be executed as easily as possible. So ease of use of the business functions. Then methods of testing. So black box testing. Black box testing is done. This is a type of testing when the internal structure, the design or the code is not known. It's not known to the person who is testing the system. So the entire coding, the structure and the designing is a black box for the tester, and he'll have to test without having any knowledge of the internal structure. That is called as a black box testing. This type of testing requires to execute the full test suite in order to uncover the issues. So the complete testing has to be done in order to uncover all the issues. Then white box testing. The white box testing is performed when the internal structure of the system is completely known. And this type of testing can easily identify the issues and problems in the system without even executing the full test suite. So, for example, while looking at the internal structure and code, if you can look at any of the defect, then you can very easily anticipate that whenever this particular set of code is used in the application, this issue is going to occur. So you don't have to test all the units or all the modules of the application. You can very easily tell the development team that this is the issue and fix this issue whenever this particular set of code is being used, so that you don't have to execute the full test suite on all the modules. That is the advantage of a white box testing, but it requires a lot of skilled testing team so that they can review the code and they can identify the bug even without executing the test case. Then gray box testing is a blend of white box and black box, where the part of the internal structure of the application is known to a tester. Then ad hoc testing. So ad hoc testing is done without any formal process or any set of predefined test cases. This is being done based on the tester's knowledge and understanding of the system. And the success of this testing depends on the tester's knowledge and creativity. If the tester is knowledgeable and smart enough to identify and uncover all the defects, that will be good. If he is not, then there is a potential risk that any defect can be uncovered. It may remain in the application uncovered. So this is the ad hoc testing. So to conclude what we have learned in this session, we have looked at the basics of quality, the need of quality function in the organization. Under the quality implementation and management, we have seen the SDLC, STLC, the QA in SDLC, defect lifecycle, quality metrics and test artifacts, levels of testing, different levels of testing like unit, integration, system and acceptance testing, different types of testing, and the methods of testing. So after undergoing this, if we look at the definition of quality, what is quality? So quality is conformance to requirements, fitness of use. It's a state of being free from defects. It's an ongoing activity. Quality is a long-term strategy. Quality is an attribute of a product or service. Quality is very difficult to accomplish. And quality is improving processes so that defects do not occur. Quality is a journey, not a destination. And of course, very, very important thing is quality is everybody's responsibility. So each and every person who is working for this project is equally important for this quality as the quality team is. So this is very important. So the answer to the question, can we afford quality, is definitely you cannot afford to ignore it. Thank you everyone for joining this session.
Thank you, Sonali, for a very informative session. Do we have any questions for Sonali?
Thank you.
Thank you very much.
Hello, Emmanuel and Olga. Do you have any questions for Sonali?
Yeah, I just was going to talk about the test artifacts.
Okay.
Yeah.
I didn't quite get what you meant by the test artifacts. I didn't really get that.
Sorry, come again. You test artifacts. You want me to repeat test artifacts?
Yeah, he does not understand what our test artifacts are. Pretty much, yeah, Sonali, if you can.
Okay.
If you can in a short.
Sure. So, yeah. So test artifacts are basically the documents or the objects which has to be delivered by a testing team. So like a test plan has to be created by the test team, and they have to deliver that to the along with the project delivery, so that every person, all the stakeholders, all the project stakeholders can review and provide comment on that test plan. Similarly, test cases and test scripts are another test artifacts. So the testing team is responsible to create these artifacts, or you can even say the documents or the scripts, and they have to deliver that along with the project. So do you have any specific question on any of the artifacts?
No, I'm okay. Now I understand.
Yeah. Now at this session, thank you, Sonali. In this session, what we tried doing is to put together a short and sweet session to give you a high-level overview of what the course is going to be, and there will be like lot more detail as we progress. This is just the review of the course that we are starting soon. Next week.
Yes, correct.
Yeah, we had about 10 people who signed up, and only a couple of them showed up. So I will have to approach everyone and see what their availability is, and maybe we'll start formal training on the quality assurance, the software quality assurance, maybe this week or early next week, depending on everyone's availability. So I will be in touch with everyone to get the feedback and see when we can start the actual training for this course. Now, the training may take like up to 30 to 40 hours, depending on how fast we go, because there are a lot of things that Sonali needs to cover, the scripting language, automation, and all that. So it will take time. It is we cannot do everything in 1 hour. It is just the course that we are starting. It is just the snapshot of what all we are going to cover. Okay?
Yeah, that's correct.
So Olga and Emmanuel, I will be in touch with you and also with Sonali, and update everyone on when we can start the course, the actual formal training of this software assurance.
All right, thank you very much.
Okay. Thank you, Sonali and Olga and Emmanuel. I will be in touch with everyone. Okay.
Thank you. Okay. Thank you.
Thank you. Thank you. Bye bye.
Thank you. Bye.